Hey everybody, welcome to another edition of VFX Live with me, Daniel Hourigan, head of effects at CG Spectrum. Hopefully you guys can hear me and see me okay. Hey Ivan, hey John, hey Alan, hey TF, how's it going? Thanks for joining me. I've been messing with some of my settings in OBS today, and I don't know, the first notification that I got said that the stream was called Just Chatting with Simon Warwick, so I don't know if I messed that up somehow, but anyway, we're here. You guys can see me, and that's good. Sorry I wasn't here last week. I don't really have too many ways of letting you guys know that I won't be streaming, but I was away. Hey Keegan! Today I'm going to keep going with the Dune stream that I started 2 weeks ago, and just see, what else I can bring to it, how I can sort of finish it off maybe. There's probably some more things that we can do when we look at the reference. We can add in a few things. So yeah, it should be a bit of fun just to play around with it. I still haven't seen Dune. Still holding out. Another few weeks for me to see it in the cinemas here. But let's dive in and see how it goes. Let me know if there's any audio issues, if the sound's okay. Helps me out when you guys let me know something's happened, like my camera's frozen, which tends to happen a lot. So I think I did a little bit of work after the stream last week. I can't remember, the week before. I can't remember exactly what I did. I think I was just playing around with lighting and rendering. But essentially this is what we got to by the end of the stream, in terms of the effects anyway. And just for a refresher, what we're kind of going for is this. So, we're a little ways off. Obviously the look of this is very different, it's very desaturated. But, there's still quite a bit of work that we need to do. I was talking to, Ivan, you're here. We were talking about this in our Q&A, our CG Spectrum class. And, talking about this event that sort of happens on the left here, this explosion that sort of pops up, and talking about how that could be a separate effect. So, that could be an interesting thing to incorporate. And, looking at the details of this stuff, there's a lot more density here, and there's probably a lot more going on in terms of it's not just pyro. There's maybe, I don't know, maybe there's a bunch of different pyro sims, and maybe there's some grain sims or particles as well. Hey Axel Visuals, thanks for joining me. So, adding that stuff in, and then looking at how to integrate the ground better, and potentially the character footsteps that you can see here, although they're pretty minor. And then maybe retweaking the framing or the animation of the worm just to make that slightly more interesting for ours. At the moment, maybe it feels a little small, the worm. Yeah, so maybe we can change the framing to accentuate that, or maybe just make it bigger overall. So it's been a while since I've had a look at this. Let's refresh our memory. We've got this tiny little cone worm, and we've got these two sort of areas of sand being generated from a procedural kind of mound that we're then sourcing into PopNet, which is giving us let me turn the lights off, which is giving us these little bursts. And then, let me make my point size. Practice makes perfect, TF. It's just, everything takes time. And the more you practice this stuff, the better you'll get. So the PopNet is generating those particles, and then we're running that into a pyro solver, which is then giving us these kind of puffs. And merge all that together, and we get that kind of thing. It's like a little traveling volcano. And then finally we merge in our worm. Oh, sorry, our ground. The worm's actually in a different render object. So there's our procedural ground. and then those two on top. So let's see how this renders. I think I did set something up for it. You can see I've got an environment light and a distant light in there. Let's have a look and see what happens with this. See what it looks like. Wait for the displacement to calculate. It's always a bit of a slow step in Mantra, is just waiting for that geometry to be calculated and computed, because it is generating actual three-dimensional geometry when you have a displacement map on. It looks like I've got my color correction on. Turn that off. Okay, so we've got something here. Let me just take the pixel samples are already at 2, and I'm already at half res. Quite slow. Let me just turn this down a bit. Pixel samples of 1. I can put my stochastic samples up to improve the quality of the volume, even though I have low pixel samples. Alright. Well, it just seems kind of slow today. Oh, it looks like I'm missing the ground. I'm using candidate objects, which is taking the view flag, but it looks like the ground itself is not coming through here. Let's check out what I did. I find often when you render like this, where you merge everything together, it's not actually a good idea. It can cause, can cause all sorts of issues, especially when you have volumes in the mix, because volumes tend to sort of change the way, they're shaded differently, so they tend to kind of mess up things when you merge them together with other geometry. So what I might do is actually start setting this up properly, where I'll go out from my pyro solver. I'll call this out pyro puffs. And I'll just start sticking nulls everywhere. So what's this one? It looks like I don't remember doing this, but it looks like I created a little volume. I guess that's, maybe just trying to tie it all together. So let's just call this out hill volume. I don't know if we need that or not. And then we've got our particle mounds. So probably what I might do here is go out pops in first, and then maybe with this one we'll call this out particle hills, or out point hills, probably a better word to use. And then what have we got here? This is our ground. So I'm going to put a null down here and say out ground mesh. And then this kind of node becomes our setup object, and then we start generating, and I'm sure you've seen me do this before, render nodes. So let's go render pops, and I'm going to object merge that out popsim node. So out popsim, and there we go. And then within here I can put some render specific settings for my particles. And then I'm just going to duplicate that and go render dust. Oops. Got an object merge already in there, so pyro puffs. Render, let's see what else we've got. Render point hills. And it makes it easier when you like rendering in multiple layers, multiple passes, to do this kind of workflow, because it means you can turn them off easily. This one I'll do render ground, and then I'll disable this ground node. So then we've got our character, our worm, and then our different render layers. So let's just go through one by one and check out these layers for rendering. So let's render pops. And this is something where we might need to, you know, set p-scale, also set up a material if we haven't got one already. Okay, so there we go. Particles are ginormous. So let's go and see what attributes we have here. We've got, it doesn't look like we have a p-scale. I was hoping for an ID. So there we go, we've got an ID. So let's create a variation of p-scales here. So at p-scale equals rand at ID is going to give us scales between 0 and 1, right? Obviously that's too big. One thing you could do is just multiply that down so that the lowest, you know, this output's between 0 and 1. If you multiply that down by 0.1, it means that 1 becomes 0.1. And if you go, you know, down like that. So that's an easy way to do it. But if you wanted to be more specific about, you know, what you're outputting from here, you put it in fit. So fit 0, 1. And then you can specify the minimum. So you don't really want the minimum to be 0, but you could have it be quite low. And then, you know, maybe we'll go something like that. See what that looks like. So there's a range. You know, even make it even smaller if you wanted to. That's probably okay. Sometimes, you know, you want to raise it up a little bit, depending on the scale. But, yeah, there we go. That doesn't look too bad. Now, you could also... Now, the reason I've used ID there is because ID does not change every frame, whereas because this is a particle sim adding points all the time, PT num is dynamic and it will just keep changing every frame. If you have a look at PT num, you can see on this frame 295,000 points, 320. If I go to the next frame, it's going to change and that's going to reorder the point number. But the ID remains consistent from the birth of the particle to the death of the particle. So the scale will remain consistent. I apologize for the rain today. It's kind of patchy, but it's really loud in this room. I don't know if you guys remember a couple of weeks ago. I'm just going to turn my mic down a little bit. So hopefully that'll cut out some of the sound. Because it's... Yeah, because I'm in a shed, in a tin shed or a room with a tin roof. It really echoes in here when it rains. Alright, so the other thing that we could do here is give this a color, a random sampling of color. So we could say at CD equals channel ramp. We'll call this, you know, color. I spell it with a U, but I'm in the habit of spelling it without a U just because that's what Houdini expects a lot of the time. So we're going to create a color ramp and we're going to run it over something. So, you know, whenever you create a ramp, you need to give it data to use. And I'm going to do the same thing, actually. I'm going to run it over random ID. And what that's going to do is then give a random sampling of the ramp for each particle. Now, that alone will create a ramp, but it's going to create a spline ramp. So it's not going to give me a color ramp. If I want to force it to give me a color ramp, I'll wrap it in a vector. And then when I hit the create spare parameters button, I get a color ramp. You can change it if you get the wrong one. You can change it up here if you go to edit parameter interface, find your ramp and flick it over from ramp type float to color. But that's a way to force it in the code. And now what I can do, what you'll see, is that if I choose infrared, for example, I should get a random sampling of these colors. You see, there we go. So the random value is giving each point, you know, a different value essentially, and it's sampling then differently on the ramp. So, you know, this red point here is getting a value that's close to 1, these purple ones getting a value that's close to 0, and everything in between. But we don't want that color, we want kind of sandy tones. So let's just replace these with some sort of more desaturated sandy colors. Pretty close. The more flags you add as well when you're doing this, you know, the more variation you'll have. You you can even sort of add. So let's have a look at that. Interesting kind of blue tone here. I don't know what that's coming from. So you can also add like a little spike here. So like do something like that, and then you can just kind of insert a little random color in there, just for a little pop of something different, you know, even like a really bright yellow or something. You can see just you get this random distribution of one little color, but because you do it in a very small area of the ramp, it will just be a very small kind of sampling of points that get that. That can be interesting with sand, you know, you tend to get, probably not on a shot like this, but macro shots of sand, you get all sorts of different colors. So it can be quite interesting to, you know, to play with that. I'm just going to turn off half res and go full res so we can see this a little clearer. Even, you know, rendering at pixel samples of 1 when you're doing sand is kind of, it's quite noisy, so if you turn it up, you can see some more of the detail a little bit. And maybe we're too big on our P scale here. So let's go back and just adjust that. The smaller you go, the more points you might need to add in. If you go really, really fine, you may just need to add in a lot more points to fill up the space again. There we go. It's not looking too bad. We can, yeah, we can always change the color later or whatever. Alright, so that's one down. Let's turn on the dust, see what that looks like. The dust is going to be potentially the slowest thing to render here, just because we have an environment light and a distant light actually will be fine, but the environment light is going to make the dust really quite slow. If I turn this off, you see how quick it renders with the environment light off. So if you don't need it, it's a good idea to render volumes without environment lights. Sometimes it's good. In this case, with a really transparent dust that we're going for, I don't think it's necessary to have an environment light. But I do want an environment light to light everything else. So rather than turn it off, what I'm going to do is actually exclude it from the dust. So I'm going to, under light mask, I'm just going to put an exception here. I'm just going to do except env star. And there you go. So no environment light on the dust, and you can see it coming back on the ground, on the grit. That means we get a really nice quick render for our smoke. We don't get the environment light, but we do need to tweak our smoke or dust shader. And the simulation itself is pretty lame. I mean, it's very, very low res. You can see lots of kind of blocks. Hey Ash, look, yes, it certainly could. Definitely, well, with Mantra anyway, CPU speed is important. But yeah, it does take an eternity on a good PC as well. It's, you know, things like what I just did are things that you can do to improve that performance. And as I've mentioned many times in the past, you know, I usually always render half res. Sometimes when you're rendering really fine stuff, it's good to check at full res just because you can see a lot more, but half res does, you know, help a lot. So you can see it's only 15 seconds at the moment. It's low res, but yeah, it's pretty quick. For the dust, what I'm going to do is ditch the shader that's on here that's been generated by the wrapped up pyro solver. This dude, the look tab of this creates a shader or manipulates a shader that's embedded inside here. But so that I have greater flexibility, what I'm going to do is delete that shader. It's a primitive attribute, shot material path. That's not deleting the shader, it's deleting the path to the shader that is stored on the object. And then you can see it has a default look that it will render. But in order to change the color, etc., I need to create my own shader. So I'm going to go to the material context. I'm going to create a material builder. And I like to create my own shaders for pyro and dust. It's pretty simple. I'm sure I've done it before. compute lighting, a volume shader core, layer into layer, and then we're only dealing with density here, so I'm just going to bind density. Plug it in. I'm going to apply this shader to the smoke. Okay, nothing changed. Hopefully it applied it. Let's see, change the smoke color and see if it changes. Hey, there we go. Whoops. So now we can get a sympathetic color to the sand, so it's not super grayscale anymore. Let's check out our reference. This is heavily desaturated, this scene, but you can see the tones that they kind of have, or the tone. It's very kind of monotone, but it's a kind of grey. I think we'll add a little bit of brown to it. There we go. Alright. Maybe a little more saturated. I think we'll go for a slightly more saturated version to start with, and then we could always desaturate it in comp if we wanted to. Okay, so I'm going to rename this dust. Hit save in case it crashes, as it usually does. Let's turn on the ground now. See what the ground looks like. And what you'll notice is that all of this grit that we were looking at is kind of invisible. All we really see is this stuff here above. Okay, so the ground, you know, needs work, significant amount of work to make it look, you know, much better than it does presently. Let's turn the worm on. Do the worm, as they say. And that one's taking ages because it has displacement on it, but let's see. It's quite dark. This one is quite light in the trailer shot. Not sure why our one is so dark. Let's check out the worm shader. So we've got teeth, we've got principled shader 1. Got a displacement. Oh, my base color is very, very dark. Don't really know why I made it quite so dark. Maybe I was going for something, some other kind of look. And I might, just for speed, I'm going to turn off the texture displacement and hit stop and re-render to force that to update Mantra through an error when I did that. Hopefully, it doesn't even look like a Mantra error. It looks like a bad error, but hopefully it'll be okay. Oh, and you can see the distance that displacement is actually offsetting that surface. You can see how this is all shrunk in now. So it's super dark. Let's turn it up a bit. Whoa. Okay. I feel like something wacky might have happened to Houdini when I did that. Have you guys been using Houdini 19? How are you finding it? I'm finding it a little bit buggy, I have to say. There's our worm back. Yeah, absolutely, Ash. Noise is a constant problem with renders. You know, and you just have to increase samples to get rid of it. There's an acceptable level of noise that you can deal with, but then, you know, you certainly do need to crank things up to get rid of it. you can see, you know, this is incredibly noisy because my samples are very low, but these samples would need to go quite high to get rid of some of that noise. But, you know, understanding where noise comes from and how it gets created is part of it, you know. So knowing that environment lights contribute noise. Hey, Robert, how's it going? Knowing that environment lights contribute noise, different types of shaders will create different types of noise, and, you know, all that kind of stuff. It's kind of important to understand that. Hey, Robert, we are kind of creating this sort of, not exactly the same, but yeah, I agree, Alan. I tend to wait as well, but, you know, I kind of like I do still have the other versions, and I tend to work in the other versions for a while until all the bugs get ironed out. But I do like kind of investigating the new features and keeping abreast of all the updates, because, well, as a teacher, it's important to do that. But you know, it's good to kind of see what's new and play around with some of these things. But yeah, I find that I can't remember now what bugs exactly I've encountered, but I have noticed quite a few, which I should report, which is the good thing to do. You know, help out side effects to make things better by reporting those bugs. All right, maybe a brighter light is good. I think having the environment on might help as well. Let's check that out. I've got this kind of deserty type environment. I don't know if that helps or not. Maybe not. What it's good to do, though, when you do turn on a background is you can really see the density of the dust that you have. You know, certainly for things that have, like very thin alphas, they tend to disappear a lot on a background. So, you know, now I might go to my dust shader and crank it up so that I can see it. It's one thing when you're always working on black, you don't really notice that until you get into comp, and then you're like, my smoke is too thin. I have to go back and re-render. So it's always a good idea to chuck it on a backplate in the render while you're testing your shaders and just see kind of what you've got. You can see our points are really disappearing as well, and maybe part of that is the half res, but maybe I do need to just up them a little. You know, I kind of maybe took them down a bit too much. But as I said, you know, you probably might need to increase the number. Well, I think, you know, the next thing in terms of rendering and integration is working on this ground. That's really something that's, you know, is going to help. Let's have a look. So we've got this ground here. I'm actually rendering the wrong one. I'll turn that off and do this one. And I don't know if I have a material on this. Doesn't look like it. Let's check. No material. So let's go and create one. Hey, Anwar. Cool. Thanks. I'm going to drag that on. Call it ground. And we can use the point color that's stored on the geometry. But perhaps, you know, perhaps we go and find a material somewhere, you know, a displacement map. I think we were using one for the worm. Let's I have stopped that. That's good. Let's turn on the texture. So I had this dry ground one. Let's try that and see. I'll put that in the displacement for the ground, but I'll also grab it as a texture and just swap it over. I have a diffuse texture here, so let's have a look at it as a diffuse. I'll turn off the displacement now. Turn off use point color, set that to white. This base color acts as a multiplier for the texture, so if you set it to white, you're going to get the pure texture and not any reduction. And I'm going to turn off these things. So this is why it's good to split them out, because it's very easy just to turn things on and off. Let's take a look at that snapshot. I think like looking at the reference again, I think our camera framing could change. Or perhaps even the scale of the character could come down, and that would accentuate the scale of the worm. But perhaps lowering our camera slightly and maybe scaling the character down might be a good thing to try. So here's our ground. I just realised I probably don't have any UVs for this ground, so it might not look all that good. Oh, it doesn't look bad. It's got like a speckly kind of nature to it, which is good. You know, it kind of looks a bit like sand, which is what we want. I'm just going to turn the worm off. And what are my settings here? Pixel samples of 3. Yeah, let's take them down to 1. Here we go. Very slow. What is going on? Ah, there we go. Alright. Well, that's kind of cool. It's not what I was expecting, but I kind of like it. So I think what's going on here is all the way up here, you know, this is our ground plane. We haven't created any UV, so this texture is just kind of, I think, really tiny and tiling. Let's check out, if we give this a UV texture, oops, not that, UV quick shade, that's what I wanted to do. Ah, it's actually not as small as what I thought. I was expecting this to be really tiny squares, but maybe that's what this image is. Maybe the image is really kind of small. Let me check that out. Got to textures. So you can hit preview in the image loader or the file loader, and it will open up mplay so you can display your image. Takes a little while. There's 8K map as well. And there it is. There's the image. It is actually, yeah, I guess the details are actually quite small, but we're not really seeing a lot of those cracks or anything. So it is a good idea to create UVs, you know, even if they're the same as what the quick shade is, or what the default grid kind of UV is getting. Let's create them before we do anything, so that they're kind of created all the way up here, maybe just after the remesh. And then I use the UV quick shade to visualize what that is looking like. Alright. And there's our outground. Hey, there's our texture. Look at that. Cool. Let's check that out. Aha. Well, that's kind of cool. I mean, it's not really like the trailer, but it's kind of cool. Let's turn on the displacement. Oops. Texture displacement and see what that looks like. Might be kind of cool. It's always good to, you know, add your own spin on something, deviate a little bit from the thing you're copying. So I'm gonna go. Let's check out this displacement. It's a PNG, but we should still be able to open it. Looking at the displacement map kind of helps you to know what settings to choose in here. And you can see that it's not just a black and white image. It goes from sort of, you know, if we crush it, let me turn this off. If we crush it, we can kind of see the range there. So it goes from like white, there's some white there. So that area there, looking at this, you can almost tell, like, you know, looks a bit like a rock that might be sitting there. So that would be the highest part of the displacement. And then the black areas would be the lowest part of the displacement. And then the middle greys, if you have a look using the image inspector, you'll see that these mid greys are around 0.5. So this would be the kind of ground level, and then this would be high, and then these would be low. So that's why you have this offset of negative 0.5, because if you just did a positive effect scale, the whole ground plane would rise up and you'd get no negative stuff happening. I mean, you would get negative stuff happening, but basically the negative part would be the kind of original ground plane position. Why this is important is if you have other stuff interacting with it, like a character running across the ground, you don't want to displace into that space. So by offsetting it by negative, you can see how the whole thing is rising up now a lot. By offsetting it by negative 0.5, it makes it kind of where it was before you displaced it, but then the white values push up and the black values go down. I don't know if that makes sense. I'm going to set the effect scale to 1. And let's see how big that displacement is with an effect scale of 1. But some displacement maps are not like that. So some will just be black to white, and then you don't want to have an offset in those. There we go. So that looks pretty cool. It's a nice kind of texture. I don't know if it kind of suits the environment. It's kind of doing some weird bubbly stuff to our mounds here. But let's turn on the worm. So you can see that there's a rock there. That's probably what we were looking at with the displacement map, that high section. It actually looks like a 3D object. Here's the wormy. Interesting how that worm affected the tone of the color of the ground as well, just from that kind of bounce light or shadow that it's casting. And yeah, the worm, you know, by comparison, feels very... I guess that's got displacement on it, but it feels very kind of flat and dark. So it could be interesting to turn on that same texture for the worm and see if we can get them into a kind of similar space, at least for starters. Set that to white. Slow process, this you know, render stuff, but it is important. You know, spend the time on it, and you'll be rewarded with a cool looking shot. But if you don't spend time on this stuff, then you know, you can have the coolest effects in the world, and they might just be let down by your you know, average lighting. Sometimes you can get a bit stuck in this generating scene when you do some updates as well, so I usually just stop it and hit render again, and hopefully it'll force it to calculate a little faster. There we go. You can do it. There we go. Let's turn off use point color on the worm. It must be multiplying, because I set the base color to 1, so it should be light, but it must be using the point color. Wow! So many wacky things going on. Fun times. One of the issues with this interactive renderer is that because it's auto-updating all the time, it doesn't create individual render files. So basically, when you render, it stores that rendered geometry in a file, temporary file called an IFD. But when you're rendering this way, it does not do that. It creates, well, it does create one, but sometimes it doesn't update it. And that's when you'll see things kind of stop changing. There we go, that's what I wanted to see. So, you know, sometimes you'll make a change and you won't see it in the interactive renderer. It won't update. You maybe think that it's broken or that you've done something wrong. But in reality, maybe it hasn't updated that temporary render file. It happens when you do big changes, like turning on 3D displacement, for example. So by stopping and hitting render again, it forces it to flush that temporary file and recreate a new one. I find myself having to do that quite often. So it's just something to watch out for. Well, there we go. Now we've got them kind of in the same space. This worm definitely needs work. It's very kind of meh. But it's kind of cool seeing them in the same space. You know, they kind of feel like they're part of the same world. And now what I could do is potentially, just to change the worm a little bit, is go and just darken it down. And then it will maybe feel a bit separate. And that, yeah, weird. Hit stop, render. It shouldn't break like that. I am in the habit of using this interactive renderer now, but you know, usually when I'm working in production, I use the mplay, render to mplay, and then I have it there stored in an mplay window, and every time you hit render to mplay, it generates a new file and it generates, you know, a new render. But I like having them all there. So instead of having to remember to hit snapshot, every time I hit render to mplay, it just renders and spawns a new render, and then I can just scrub my mplay or go back and forth and compare, you know, compare what I was doing. Okay, so the other thing we could do to the worm is maybe, you know, it doesn't have any reflection. Perhaps we give it a little bit of reflection and maybe make it quite rough. Hey, Mimo El Mimo, I'm going to have to Google Translate that because I can't read that. Copiapo chili. Yeah, translate this so I can see what you said. And the interactive render is broken again. Oh, you follow me every Sunday with my entertaining classes. Cool. Thank you. I'm glad you enjoy it. What is Radio Festiva? Is that a radio station? That's cool. Alright, well, you can see a bit of reflection on there now. It sort of changed it slightly. I don't know, you know, I played with this a lot last time as well. You can play with this stuff forever. But let's now get our dust and points back on and see kind of what they look like. And we may need to swing the colors around. So dust, not too bad. Festive Radio and Atacama TV. Cool. Well, thanks for joining me, Mimo. Point hills, render pops, that's what I wanted to do. Not point hills. So, you know, the next thing that I kind of am thinking about in terms of integration is kind of, this doesn't look like sand, right? This is kind of, you know, cracked ground. And whilst it looks cool, it's not kind of, you know, it's not really what I was going for initially. And how to make that kind of feel like it's tearing up the ground rather than just, you know, points are being emitted out of this ground. That's kind of, you know, that's kind of the big thing. So, you know, I do have these point hills here. So we could go and take this same wrangle and color business. Maybe apply that to that. Though, we don't have IDs for these points here. We could create them though. If we come all the way back up here, we've got this scatter that we're creating. Could we create IDs? The issue here is that these point numbers are going to change every frame. So perhaps doing a random is not a great idea. I haven't created a rest position either, which could be a good thing to do right up here with my UVs, or I could use the UVs, but let's create a rest position. So that's going to create an attribute. At the moment, the ground is not moving, so it's just going to be a kind of 1-for-1 P and rest are the same. But as soon as this ground starts moving, you'll see this P position now is changing. Oh, and the rest position is changing. That shouldn't be. Why is that changing? I'm changing the P position here. Oh, you know what? I think it's changing because the point... I think what we're seeing there is just the rest position is not changing, but the points are changing. Let me turn this blast off, and then we should see the rest be the same. There we go. So... oh, it's weird. It's kind of not really updating. This point position should be changing, should be updating, but we're not seeing it update. It may just... oh, there we go. There's some updating ones. There we go. So see these ones updating, but the rest is static. So I think why it looks like it's changing here, it's just the point counts. Because we're deleting based on a selection, the point counts are just updating. So we've got a rest position now that we can use to drive something. You know, we're going to use it to drive maybe the color on here. If we have a look, this actually doesn't contain the rest position, and it's because we're using a point replicate. What I'm going to do is take out point hills here from this point, and I'm going to do this point replicate in this new object. But first, I'm going to create some color. So, oops, @vop. Do an attribute vop. I'm going to bind the rest position. Hey Craig, how's it going? 3 float vector, so I'm going to do a rest position and a turbulent noise. The reason I'm doing it off of the rest instead of P is because the P position is changing every frame. So what you'll see when I do this is that we get this noise kind of, you know, it's sort of, as this stuff moves through it, the noise is sort of there. But if we do it on pause, it might kind of actually be, well, you can see it's how it's moving around a little more. I don't know, maybe it doesn't matter because these are moving. Doesn't matter as much. I don't know. Well, we've got it there if we need it anyway. So what we could do with this black and white color is actually apply the same ramp that we did here. I'm going to copy this ramp. Copy parameter. Just finished work. Wow. Put a ramp parameter in here after the turbulent noise, then paste those values. This crashed last time I tried it in Houdini 19, but there we go. And you can see those weird yellow ones. We'll probably just get rid of that this time because it doesn't really work when it's not random. But there you go. You can see I can get like a, you know, a ramp sampling of that noise now. It's a little bit different to the random, but what I could do is up the frequency, make it really high, and then you kind of get a similar effect. Maybe we need to change this, have less kind of, you know, less of those light ones, or maybe just less flags in general. The other thing you could do is have another noise in there. Maybe this one will pull off the rest just for fun, and you could multiply one noise by the other to create some difference of shapes. Let's I always just plug the CD in, just see what's going on. So this one I'll make a low frequency. And yeah, you can change the noise type if you wanted to. Play with different ones. I kind of like alligator. And then what you'll get is, see now how that noise is kind of reducing that stuff there. So you can kind of play with that. You know, you could crush it, change it, change the minimum so it doesn't multiply it all the way down to 0. You can crush those values. Yeah, whatever, you know, whatever you like. Sometimes it's good to create combinations of noises. And then when we go into our pop replicate, we can just copy source attributes and it will copy those colors on like that. Or we could potentially do this after. The point replicate now should get the rest. And we could do it there. And that will give a slightly different feeling to that stuff as well. Whereas if you copy the color from here onto the point replicate, what you're going to get is clusters of the same color. So see how those single points are now being turned into clusters of points, but they all have that same color, whereas this one done afterwards will potentially vary those colors through the cluster as well. You can see how you got multiple colors there within one cluster, but previously it's just one color. I don't know. Yeah, you gotta play with it. Whatever works, but it's good to understand, you know, that happens. Okay, so let's see. We've got here our P scale, which we could add on afterwards, and we'll just get rid of this vector line about the color. Incidentally, you know, if I delete that color line, I'm still left with my ramp here. So one thing you can do is just delete all spare parameters and it will get rid of that ramp. Now it's gone. And let's check this out. So I've done some changes to my base grid, which was driving my whole effect. So my .NET is recalculating. And there it is. So I don't know what frame we were rendering before. We were rendering frame 48. For comparison, it's always good to try and do the same frame. Perhaps one thing that we could actually do is try to utilize this texture to drive the effect from the start, and it might actually be a good way to, you know, create some really interesting effects. And maybe that's something that I'll try next. I'll just finish these point hills, and I haven't actually given my pops a material. I haven't given one to the point hills either, but let's just see what they look like. Yeah, I was just kind of thinking that it might actually be cool to utilize this texture now and make it part of the effect, rather than just slapping it on top of everything. It might actually be really interesting to use that to create the shapes for the bits of dust and stuff that peel off, and it might actually make it look really, really quite cool. Let's see what this looks like. So let me turn off the ground, see if I can see anything. Okay, so those point hills are there, but they're looks like they're below the ground. So what we might want to do with that ground is just, you know, because we are displacing it, might just peak it backwards slightly. This is displacement that it's showing me in the viewport. Hopefully it won't look like that when we render it. let's check. The viewport representation of displacement can be often a little off. Sometimes it's good to use it as a guide. At least it tells you that there is displacement, but it's not always the best. Let's see. Yeah, as you can see, it's not doing that. Okay, so let's turn on our point hills. Still can't really see them there. We may need to, make them slightly bigger. Let's take a look in the viewport. So they should be sitting, well, it looks like they're sitting quite a lot in front. Maybe the scale. Alright, I'm going to turn everything off except those. Maybe it is just the scale of them. Or maybe they are just kind of blending in. Because they're definitely, there when we render without the ground. Maybe they are there. Maybe it's just the pixel samples and stuff that's making it a little hard to see. Let's make them bigger. Hit stop, hit render, make sure they're not like being omitted from the IFD file. They don't have a material as well. I don't think that should matter, but you never know. Also, maybe turn off displacement on the ground and just see if that... I did move the ground down, but maybe it's displacing into that space. Oh, there we go. So it is displacing into them quite a lot. One thing that you can try here, I'll turn that back on, and I'll actually grab this displacement map. So, they look awful now, because I made them too big, but... Where does the texture in the sand not change when the worm makes it move? The texture in the ground does kind of distort with, you can see it lift up as the worm is pushing through. So, yeah, and that's what I'm thinking. Oh, maybe I'll just abandon this for a second because I have a cool idea, which is, all the way back up here. When I've done this stuff, which is kind of okay, but it's also a bit, it's a bit kind of not super high res. All the way back up here, a cool thing that I could try is, I might have to actually make this really high resolution, but we've given it this UV texture. In an attribute VOP, let's bring in that texture. So I'll use a texture node. Plugged into UVs, and then here I'm going to paste that displacement map. If I plug that into color, we should see that. Interesting. Let me promote the texture map path and paste it in there. Why is that giving me that? That doesn't look right. Well, let's try the JPEG instead. I wonder if it's my color settings in my viewport. Lame. Come on. Weird. Well, so that should be showing me that texture, but it ain't. So maybe that display is not working. I don't know. I'm just going to load that in. I don't know why it's showing me that in blue. But what I'm going to do is try and displace the geometry. So I'm going to use a displace along normal. Plug P and N in there. And then this texture color into the amount of the displacement. And then output P and N again. And hopefully it will displace this geometry. It doesn't really seem to be. What I'm going to try here is just, let's take this over here, grab my grid, duplicate it, whoops, and I'm going to give this 1,000 by 1,000 rows. And I can't see it doing anything. So I got my UVs. Oh, you know what? They're vertex UVs, and this is a point VOP. So let's attribute promote these vertex UVs to points. Ah, something's happening. Please don't crash. Hey, look at that. I can see displacement now. So, and then if you put a facet down, because this is kind of affecting the normals, put a facet down, then you can actually see it. So we've kind of, there's a bit of resolution stuff going on here, but you can see now we've got that as a 3D displacement. What have we got? We've got 1 million polys, which is high, but it's not, it's not the end of the world. The texture itself looks a bit stretched to me when I look at that. So now I should be able to see it as color. But it's coming out blue. I'm going to do vector float. Ah, there we go. So, yeah, it looks a little stretched. Crashing, yeah. It's always always in the back of my mind. When's it going to happen? When's it going to crash? So if I crush this a little bit, I can sort of see this a little clearer. And you can see it's sort of stretched in this direction, probably because my grid is originally stretched. So what I'm going to do is in the Z axis, I'm going to scale these UVs. And it doesn't seem to be doing anything. Not why. Oh, actually, I'm going the wrong way. There we go. So you see how that now doesn't look stretched. And if we have a look through the camera, back here. And we can do the same thing with our displacement, where we can have an offset and a scale. So we could actually feed that into scale. Oh, is that what I want to do? No, I want to... how do I create that offset? So amount, scale. Maybe I can subtract constant. Maybe 0.5. No. Oh, subtract 0.5. We're trying to get the same effect basically, where we're not changing the position. We want the kind of middle position to be same. But you can see how that's shifting. That's not what we want. And that is also not what we want. I don't know why it's 0.25, but that's kind of not too bad. It's probably a better way to do it, but whatever, it doesn't matter. That looks about right. Middle. Who knows why it's 0.325 instead, but whatever, doesn't matter. So we've got these now, which is kind of cool. You know, we've got these shapes, which we could utilize. And we could also potentially crush this map. I wonder if we could do that. Let's try. Or, actually, I wonder if we can select based on normals. Let's try that. Group, points, keep normals, direction. Maybe that way. What I'm trying to do here. Oh, I need to turn that off. So what I'm trying to do is just select the faces that are. Oh, there we go. I guess it looks like they're all kind of getting selected when I do this. Oh, maybe I should recalculate normals first. Aha, there we go. So you can see when I do that, it's kind of, you know, how it's selecting certain areas. I was just wondering if maybe I could select just the tops or just the centers. Oh, there we go. That's kind of, that's sort of it. Not entirely, but sort of. What I'm hoping is that I can isolate just the bits that aren't the cracks. Let's try that last. To try and create those shapes. Not too bad. You could also try using the measure SOP to calculate curvature or the gradient or something like that and utilize that as a way to isolate. So, you know, maybe we calculate the curvature, for example. And then we have an attribute called curvature on there. Make it a point element type. Then it's a point attribute. And then let me just put a color node down to have a look at it. Oh, I guess I could create a marker, but whatever. Curvature. There you go. See how that has kind of given me... That actually works pretty well. To give me those cracks. To isolate those cracked areas. So that's kind of cool. Let's have a look at that. So in a wrangle, I'm going to use curvature to delete points. So if at curvature, I don't know what the values are, but let's just do 0.1. And then we'll have a look. Remove point 0, comma at pt9. Okay, well that did something. Let's look at the curvature values. So they're actually between 0 and 5. So let's have a look at that. We can just play with that. Oh, yeah, that's pretty cool. So we can just play with this value. Greater than 1, so you can see, you know, what happens as you go up. Or you could do less than as well. Less than 5. Less than 4. Less than 2. Less than 1. That's probably kind of okay. It's better than what I was getting here, or yeah, different, I suppose. I don't know if it's better. We could also maybe do both. So we could do the group and that. And then we end up with maybe something. I'm going to put an add down because you can see I've got a whole bunch of points that aren't connected to anything. I'm going to do polygons, remove unused points, and you'll see those go away. And now I've got these kind of little islands of stuff. I could run this through the same setup. So, don't need that Voronoi fracture. Got this color stuff happening. Displacement. I probably don't need to do this turbulent noise now. You know, so that was displacing that stuff. Maybe I need a little bit, but you know, we've got a bit of detail in this grid now. Let's just grab this before that part. There we go. Oh wow. That doesn't look too good. What are we doing there? Displace normal. Let's check out those normals. So you can see how that's a little bit funky. We're getting some crossover there. So what I might do is, instead of using the normals that exist on the geometry, I'm just going to put a constant in there and pick 1 as my vector. And then you can see how they're no longer crossing over. Because the normals in the cracks are kind of pointing inwards. Yeah, you know, I mean, this is a cool thing about Houdini. You can just do that, fix things. And then, so maybe here, after this stuff, I could do that kind of blast and attribute wrangle. Maybe before the scatter, even potentially after the scatter. But you'll see that group will persist, and that curvature attribute persists as well. Now we've got these kind of interesting shapes, which tie into the greater, you know, kind of texture that we've got. And those might just feel a bit more interesting. I don't know. Yeah. Gotta try these things. Let's see. Am I using color in here at all? Doesn't look like it. I'm just going to reset the color to white. And then I am sort of changing the length of those particles as they... so I'm multiplying that V by CD here. So that is important at that part. Yeah, I don't know. What do I want to do with this? What do I want to do? I wonder what this would look like if I poly extruded it down. I mean, maybe it's kind of, maybe this is silly, and maybe I should just sort of recreate this this surface procedurally so that I can actually do more with it. And that, yeah, that's always the issue when you're using a texture, is that it can sometimes be, you know, a little problematic to kind of work with. And you know, you get areas that work and areas that don't. You end up with these meshes that have holes in them and some dodgy, you can see like these dodgy lines that are kind of created by doing this technique. And maybe it would be easier to just kind of create, you know, create this from scratch or something. I don't know. Let's try it. Let's see if we can do it. What I'm thinking is I could scatter points. Oops. In Houdini 19 they put this scale node in, which now every time I go to put a scatter I get scale instead. So what I'm thinking is maybe I could use this attribute transfer method to from, let's put a color node down. So we're going to go, you know, I do this for everything, but it is a kind of good way to do stuff. So you can see I can create kind of, you know, shapes like that. If I turn off relax on my scatter, it'll be a bit more random. And in fact, I could potentially just generate a map like this using Voronoi noise. Or a whirly noise, or wally, or whatever it's called. Oh, there we go. So maybe I'll just do this. What you could then do is use a displace along normal to create the divots in the geometry. What did I do? Wrong. See that? So, yeah, could use that to... So actually, I'll just take that from there. And let's see what else I could do here. So that's my noise. Turn that off. And it's a little bit, you know, uniform. So let's try doing this, feeding a turbulent noise in and adding it to the position that is driving the Voronoi noise. So what that's going to do is kind of, it's essentially like you're feeding it a geometry that has its position changed, but we're not getting that, we're just getting the noise result of that. So what you end up with is a kind of wiggly noise that's then being applied back to the flat plane. So, you know, you can see the difference there, how it's sort of very ordered, but then we're manipulating the geometry that's being fed in to the Voronoi noise, and it gives you some variation, some interesting kind of, you know, wiggly stuff going on. Play with that. You can see if I really push the amplitude, I get this curvy noise, which is quite cool. That's probably a little much, but let's change the frequency. Yeah, you can see, you can get some really cool patterns when you do this technique of manipulating the position that's then feeding into another noise. Turn that down a bit. Well, that's kind of cool. Let's check out the displacement. Not bad, but what we actually want is, I think, almost, yeah, it's kind of like that, but we almost want the, I don't know if we want the inverse, but we want those kind of cracks as well. Let's see if we can get that happening. So, oh, it's interesting. Not quite. Let me turn this off for a sec. I'll put that to color. Okay, so now I can see a bit better what's going on. You've got these different outputs as well, which you can have a look at to see. These are not going to be colors. No, these two, distance 1 and distance 2, kind of the ones to play with. But we might be able to get some data out of one of those that we can't get from the other one. It looks like maybe... What happens if I change the jitter? Ooh. It's kind of cool. I think maybe having the roughness in here is, let's see, no, maybe not, I don't know. Give me those lines, there we go, those, that's what I want. But they're sort of a bit kind of thick. So if I output that as negative displacement, there we go. Crush them a bit. And then if I take a different fit and do this, whoops, do this displace again, rather than combining it into the one, just so I can kind of control it a little bit, and then take this one and plug that in there, 0 to 1, flip it. Hey, look at that. So, you know, you can see I'm basically adding then the depression in the center as well to create this interesting complexity. So I don't want it to be that much, just want it to be a little bit, and perhaps you can see how when you crush it, you know, you can sort of change how that's applying. I don't know, there's probably lots of ways of creating this, but yeah, that's kind of cool. And then you could always, I guess, clamp the values. So if you did a clamp here, actually what I'm going to do is split the components into 3. So now I've got X, Y, and Z, and then I'm going to do float to vector, recombine them. So if I do this, that is just my X and Z components. You can see how I have nothing up. Now if I plug that one in, that's my Y. But what I could do is plug that into a multiply or clamp. Let's plug it into a multiply first. I'll promote parameter and plug that back in. And now I've got this kind of control for how much of that displacement I'm getting. Maybe that's all I need. But I could also put in here a clamp to clamp that to a certain value. And you can see how I can sort of limit the displacement to a certain depth if I wanted to. I don't know, it doesn't kind of work the way I was expecting, but and I could do the same with the Y. Actually, it doesn't look like it's in positive values. Looks like it's just sitting right on the surface, which is okay. Hey, okay, how's it going? You made it. Alright, so I don't know. I mean, yeah, it's kind of interesting. Let's have a look at now our colors, because hopefully we can utilize some of this stuff to isolate these chunks. So, we've got that, we've got that. Maybe we're going to run into the same issue, because essentially what we've created here, or what I've created, don't want to implicate you, is I've created the same problem. It was a nice journey, but what I have done is created the same issue, whereas if, you know, so if I isolate these now based on color, delete non-selected, it's a little bit cleaner than what I had from the texture, but, you know, I kind of have the same issue. So perhaps, this is the other idea that I had. Sorry for taking you on tangents, but, you know, you gotta do this stuff when you're spitballing, trying to figure stuff out. Perhaps what we could do instead is, I'm gonna extrude volume to create a thickness, and then fracture this stuff back to the old Voronoi fracture. And in fact, I might do it, yeah, maybe I'll do it on a grid, not an extrude, and then I'll extrude afterwards. Voronoi fracture. You can see I get that Voronoi pattern. And then what I could do is, maybe I'll get rid of my grid divisions. There we go. So I get nice clean fractures. Now, I'm going to run this through a for each loop and see each piece individually. And now I could do some processing on these. So, I could, let's do a poly extrude. And I'm going to do an inset. Hey. And then perhaps I will, which is my front, back. I don't want output back actually. I just want this face in here. I think that might be the output front. There we go. So I'm going to turn on output front group, and then I'm going to poly extrude that. There we go. Alright, so what I have now is that. Right? When you look at it through the for each, you get it happening to every single piece. But inside of here, we're just dealing with that en masse. So we could do that. I don't know. We could also do a peak to shrink those down. Except it's kind of doing it based on normals. Perhaps what we could do instead is a transform with a centroid expression. This is a centroid variable that you can use. And then that will scale it based on the centroid of each piece. And that, maybe that's better. I don't know, I'll keep those to one side. We might still use those. And then what we can do is we could remesh each one of these. I do enjoy coming up with these systems. I mean, you know, I've kind of left the effects aside for a moment, but you know, it's an interesting kind of challenge to do some of this stuff. Now here's a buggy node that I find crashes often. Extract centroid seems to crash when I do this. Get rid of the name. I don't know why, but it does. In fact, I have a name, so maybe I don't need to do that this time. But I'm going to create a centroid point there. There it is. And I'm going to... What am I going to do? Attribute transfer? Is that what I want to do? Point VOP. So plug in the extract centroid into the second input of point VOP, and then get attribute to grab that position. So op input 2. Look, you can do this stuff in Vex as well. Doesn't matter. I just like doing it this way. It's a bit more visual. It's only one point, so its point number is 0, which is second input. You'll see if I plug that into P, everything will collapse into a single point. So there's lots of points there, but they're just collapsed into that position. So that's good. Now what I could do is create a distance from two P positions and output that as color. And what you'll see is that I've got this fall off now from the center out. So the distance increases from the center, from that point position. So it goes from close, 0, small values, to white, further away. If I was to bind that into just an attribute to test, you can see that I'm ranging from 0.03 to 0.6. So I could also fit that into a range if I wanted to, but it will change depending on the piece. So yeah, you gotta keep that in mind. You can see I can do some stuff there with that. Alright, so what am I going to do with this? I'm going to do the same thing. Displace along normal. P. Amount. Output. Oh. Okay. I'm going to invert this. And I'm going to do negative scale. But there we go. I don't want those edges to be displaced. So maybe I'll just just play with this and see what happens. And then that value is way too strong. So you can see I've created a little divot here, but maybe you can see how it's just a point at the moment. Maybe I'll run this through a ramp. I'll make it a spline ramp, and now I can shape this divot. So I can kind of choose a shape. Interesting what's happening in the center here. Ah, maybe it's that. I see. So there we go. So now I can create like a flat bottom, or I could change it to a spline, or a bezier actually, might be better. And then I can create a kind of nice smooth shape there. I'm going to actually promote the scale so I can do it out here as well. And then we look at the for each loop. It's going to take a little bit longer because we're adding a lot of mesh. Very uniform. But you can see we get like these, each one of these pieces is now got a divot on it, which is kind of cool. So what are we going to do next? Let's turn off relax on the Voronoi. That'll give us slightly more randomness happening. There you go, you can see we can get some different shapes happening in there. We're going to get some different distances as well. So actually, maybe what we should do is calculate, and yeah, I can do this in a wrangle because it's a simple operation just to show you the differences. Let's calculate at dist equals v at actually distance v at p, that's our input, the geometry's p position, and I'm gonna do the point expression, grab it from the second input 1, and then the attribute is p. I always forget this stuff. So when you're writing a point, you need to get all the arguments in there. So you've got your geometry, that's the first one, the attribute name, and then point number. So at pt_num. Sometimes it's different depending on what context you're writing it in. And actually the point number is not pt_num, it's just 0 because we only have that one point. So just make sure that we have all the brackets. That's going to create a distance attribute for each piece, and it's going to be different for each piece. Then to calculate the maximum distance, we could do this, where we take the distance attribute, promote it to a detail, and choose maximum. And then that's going to give us, in the detail slot, the maximum distance for that piece. And we can use that then. I'm going to turn off delete original. We can use that if we promote it back to point. Let's go point, detail to point now. Dist, I'm going to call this dist underscore max. I'm going to do dist max. So there we go. There's our maximum stored there. So we can use that in our fit. You know, we've got this source max here, so we can bind dist underscore max and feed it into source max, and then we'll always get the correct maximum value for each piece. So what we should see now, aha, we get perfect curves on each one instead of it, you know, being a circle on one of them, and if I unhook that, you'll see it go back to being lame. So now it's dynamically updating that fit range depending on the size of the object, which is great. So that's cool. Now we could add all sorts of extra variation to this, you know, based on the scatter. The scatter is what's driving the kind of original shape. So what have we got here? We've got our scatter, which is kind of boring. What could we do? We could do a point replicate, maybe, around each one. add a few points. They're being created on a box. You could scale that up to create some interesting variation. Add noise potentially. That's just going to create some really small pieces and some big pieces, just to create overall some interest. You see that? Then maybe we do it before the remesh or after. I don't know what is the best thing to do here. Let's try attribute blur, and we'll blur P. But I'm going to turn off pin border points. And maybe even turn off connectivity. And you can see when I do that, even with one iteration, I can get this to kind of smooth out a little bit. And if I do it before the remesh though, you'll see it doesn't really do too much. But I could potentially do this, where I remesh a little bit, and then remesh more after the fact. And that might change just the way, the way that it blurs a little bit. Different kind of shapes that I might be able to get. And then that can be my final remesh stage. Let's see what that looks like with a bit of smooth edges. Getting a little bit better. The other thing that I could do here is add noise to this. So we're just doing like a straight kind of displacement, which is a bit sort of plain. So, I could add turbulent noise to this and multiply the ramp by this noise. Got to get the right level. Let's plug that into CD so we can see what it looks like. And we'll do a fit. So we can say that, we don't want it to completely go to 0, and maybe we want it to go to 1.5, so it's got a bit of variation. Just mess with that a bit. Even crush it so that it accentuates it. Hey, Kachoro Magro. Watching and learning. Hopefully we'll break the Houdini learning wall soon. Yeah, well, I hope so. I hope you get there. You will. It's all about time. Time and practice. And just breaking things down. All these things I'm doing are, really fundamental things in Houdini that, are important to learn about. Manipulating attributes and understanding, just how you can... a lot of this stuff is just workflow stuff, and that's a lot of what I'm, trying to get across to you guys is, these different and interesting ways of working within Houdini. But, it's really important to understand how to manipulate attributes and how you can create things like distance. Doing this attribute promote stuff is really handy for, storing maximum values and minimum values. So if I nuke the color and recalculate, hey Rizwan, recalculate normals. Yeah, it's pretty subtle, but you can see that variation now that the noise has created. Turn the lights on, maybe I can see it a bit better. And then finally, what we could do there is poly extrude that inside the loop. Poly extrude it down, output back. We could even give it a little negative inset or transform extruded front. Gives you the ability to scale it. I don't know why our scales are kind of a bit offset. It's a bit weird. So the ability to kind of scale it out so that when we finally do our combined, let's have a look at that. Hopefully they'll kind of overlap a little bit in the cracks. There you go. So they look a bit more like stepping stones than you know, cracked ground at the moment, but it's starting to kind of get the look, you know. And what is cool about this is that it's now separate geometry. So, you know, obviously when you look at it like that, it's a bit Voronoi, so I need to do some work in terms of improving that Voronoi. But what is cool about this now is that, you know, I can do... Let's have a look at this stuff. So, you know, we had this red transfer method. If I was to use that over here, got that same thing. Let's set it to black. I've got this same effect happening. Here, I'm doing the push. Let's see what happens when I do that here. So, you know, we can see that stuff lift up. Recalculate. There we go. We can see that stuff lift up and distort. But we could also, you know, potentially, these are potential for rigid bodies now as well. So maybe over here, what I could do is do an RBD solver. Oops. Let's turn on the ground plane and just check out our position of that. So just get it right there. Hit play and see what happens. Okay, so they're just falling around and doing all that. Oops. 1.14 went the wrong way. So it looks like some of them maybe aren't as tall as others. So one thing you could also do, instead of the poly... actually the poly extrude's good, but what I could do is turn on the output front group. So the front is the bottom section there. And I could actually clamp that so that they're all the same. I could say at p.y, and I'm going to choose extrude front group, at p.y equals negative 0.15. And you see how that flattens that down? So then all my bottoms of these pieces will be flattened. Maybe that's not what I want to do, because it will kind of make all the bottoms flat. If they flip over, then it might look a bit weird. But, you know, that's something that you can do sometimes. And then I could set my ground plane to just be the same as that. And then we won't see them fall. There you go, fix that. Now, where's our wormy? Here it is. A bit tubey. There he's got a trail. Oh, we've already got one set up for this. That's good. For the pyro. But we can plug that into our collision geometry here. And see what happens. Oh. He's not moving. Animated static, deforming static. Convex hull, yeah. Hey, look at that. Okay. So, you know, it's kind of, it's a little bit different to the trailer now, but what it gives you is this really cool motion and accumulation of stuff. And also this, you know, this behavior I really like, where pieces roll over and flip and tumble over. And this could provide a really good base for sand being emitted off of these things. So, you know, if I was to then take these pieces, let's have a look at them. We've got I'll put a trail on just to recalculate velocity, because sometimes velocities coming out of DOPS is a bit wacky. And they've got velocities. But you can see these ones down here don't, or they have very low velocities. So I could Let's see, what do I want to do? I'm going to actually... Yeah, I'll just delete the points. Let's see. So I'm going to say if at length is less than 1, remove point. Okay, change that. 0.5, 0.1. Oh, I did not do that correctly. V at V. Whoops. If at length, no, what am I doing? If length, V at V, there we go. Okay, and you can see it's starting to remove pieces, so well, let's try lesson 1 again. So what you can see is that it only reveals the pieces that are moving, and moving quickly. Still getting a few there that aren't. Right at the start there, it was looking a bit weird, but there you go. So you can see those ones that are moving are the ones that are getting that fastest speed. And those are the ones that are sort of showing up. You know, basically deleting everything else that's not really moving. So we could utilize that to source pops or grains or, you know, anything from, really. But it might be cool. And we've got this extrude front group outputted. If I was to then blast and isolate that, extrude front, delete non-selected, that's now the back underside faces of that geometry. So that could be a good face to emit from. Oh, I just thought of something cool. What you could do here with this, you know, I'm clamping that extrude front down. What I could actually do here is store the original position where it's curved as a rest. So at rest equals V at P. And I might call this something different just in case I have another rest. At curved rest equals V at P. Then I'll flatten it. Just for the purposes of simulation, really. This is cool. Yeah, this is cool. I love doing this stuff where you store a position that you then, you know, might call back later. We do our simulation again. We've got a little tube. Okay. Cool thing about this is that we get this motion happening ahead of the worm as well, which is really nice. And now we do our trail, our delete, our blast. And maybe before the blast we can actually, or even before the trail or before the remove, we could actually do this. So you can see here's our flat bottoms that we've got. Yeah, there's a good one there. Let's do this. Ooh, will that work? No, it won't. Because V at P equals V at rest. It's just going to put them back to the original position. Silly, silly, silly. Curved rest. I was like, yeah, this is a great idea. But you can see that that rest position is actually just putting them back to where they started from. So what I would need to do is, well, I can utilize the proxy workflow, you know, where I have a high res and a low res version, but I could actually have that here. Let's do this. You uploaded your land speeder, Rizwan. That's cool. I'll have to check it out. So let's do this. That's our proxy. That's our high res. That should apply them correctly. Let's see. So what we should see is that we get the curved bits being output. There we go. It's like it's working. Curved bits are being output, but it's actually using the flattened bottom bits as the simulation. So that's cool. It's handy having that built in here with the proxy geometry and high-res geometry inputs. So you could do whatever you wanted to the proxy geometry, really. And, okay, so now we've got our curved bottoms. That's good. And then we could run it into the, you know, into a pop network. almost out of time. Didn't really do what I had planned to do today, but you know, this is still good. All geometry, first context. Not all geometry. I'll just do scatter onto surfaces. Then we can use the birth rate. Let's see. Okay, so they're emitting. Let's just do a pop drag, a pop force. Pop force. Cool stuff, Rizwan. I'll have a look after. Negative 9.8. Okay, so you can see that that's just raining down. Probably, you know, we'll just create a ground plane for simplicity, but you want to bring your RVDs in as well as colliders, so that they collide with those pieces. And then we want a ton of points. Turn off the guide. Guides make pops really slow. 50,000. Alright, maybe the drag's a little... killing the motion a little bit. Cool. So, it's still not really enough points. I mean, one thing that you could do, you could probably get away with actually killing them so that, you know, they die after a certain amount of time. And certainly maybe, you know, we could kill them once they hit the ground plane. Maybe that's the collision behavior that we could choose. Just choose die. Color hits, die. That should kill them on impact of the ground. There you go. Looks like they're dying. That will allow us to have a lot more. Yeah, do 500. What is that? 50,000? 500,000. 500,000. You can see now we've got a lot more. We're getting these interesting trails occurring now, which is cool. But because they're dying when they hit the ground plane, we're not ending up with, you know, millions of particles. It's still only 132,000. So that's cool. We kind of don't have those two hills like in the trailer anymore, but yeah, whatever. So let's merge that with our RBDs. See what they look like together. So these RBDs, you know, they don't have to stay as RBDs. We could do points from volume on those. How many points do we get there? 56,000. Let's go 0.05. Due to scale 1. 400,000, it's not really that many, but then we could point deform these points by these ones. So what do we got here? Middle is the rest, so we can just use that. That's the deforming one. And then you can see we get these kind of clusters of points going along for the ride. So now we've got these sort of, you know, chunks of dirt, essentially. And then they're leaving behind spray. So you could take the geometry as well if you wanted to, and just maybe have these ones sit sort of, I don't know, outside of the geometry a bit, so that it creates that feeling of sand on the surface of the geometry. You could also just scatter instead of, if you were doing that, maybe a scatter is a better thing to do, where you're just scattering on the surface. Don't use relax. And then just scatter a ton of points and deform them or attribute interpolate them, whatever you want to do with that. And then you can see how that, you know, that will keep them on the surface. And then you could also potentially do like a point jitter to create even more offset from the surface. Something like that. And, you know, go high with the amount of points. This is pretty inefficient because I'm just scattering points everywhere, but maybe it's a good idea to just scatter them in the foreground where we're going to see them. But yeah, I mean, that, you know, that could be an interesting approach for this technique as well. it will potentially be a little bit different. Let me just do this, star pop star. But I think you could probably, like, through activation or I don't know, some other methods, you could get a similar sort of two hills look to it. And maybe the size of these, you know, is just too big, and having them be much smaller would help. So, you know, we could go all the way back up here and scatter 5,000 points instead, or 10,000, you know, run it through the for each. That's just going to go through, do its thing. It's going to, you know, potentially need to be updated, but it also might just work fine. And then we've got, so it looks like we've got 2,952 pieces now. What is that? Something freaked out in there, one of those pieces. It looks like lots of them worked, but one of them did not like that. I don't know what's going on there. Which piece is this? Only show selected. You can see it is piece 327. So what we can do is kind of handy. So yeah, I just use this only show selected. When I select something, I can see the attributes that are present on just that selected face. Then I could do this. What was it? 327. Let's choose single pass. 327. Ah, there it is. So we can go in and have a look at what the hell is going on with this piece. And it's a very small piece by the looks of it. And the poly extrude is just freaking out. It's maybe to do with the transform. No, it's still wacky. So sometimes, oh look, turning the transform on didn't seem to change it. Sometimes I find when you switch it to point normal, it actually oh, come on. I can't seem to rotate around it. Switching it to point normal actually makes it perform a little better. So I mean, that piece is a bit small, so maybe we just shouldn't use it. But yeah, when you get weird extrusions like that, changing it from primitive to point normal on the poly extrude can really help. We're gonna have to wait for the whole thing to cook again, but it should hopefully not have those weird bits. You can see that one there is still a bit weird, but you can see how small it is in comparison to all the others. And there we go, it's fixed. That's good. Let's run the sim. You can see we could potentially go even, you know, even smaller again. Yeah, this accumulation in the center is something that, you know, I'd want to try and reduce to really accentuate those two mounds. Not too sure how I would do that yet, but maybe a combination of active or some constraints maybe to try and hold that stuff down. Don't know. Crazy. It's really accumulating there. Oh, you know what's happening? Actually, just realized. Our worm is a convex hull. That means it's got holes on both ends. The convex hull is just going to skin right across the front of that tube. You can see that they're not colliding or getting sucked inside there. So what's happening is that it's just a wall that's pushing them. That's why they're building up in the front there. If we set this to concave, which isn't particularly efficient, we should see now, see the collision all the way inside there, which is quite cool. And we should see much less of that accumulation in the center, and it will just sort of be around the sides. That's better. It's kind of less cool, but you know, it is more accurate. And perhaps we just need to shape our collision a little differently, you know, so that it, maybe we just get a ring, like a torus or something, instead of all this stuff back here as well. Because this really should just be inside the teeth, and we maybe don't want that to happen. So yeah, you know, needs a little love, but I thought that might be an interesting way to get some cool motion that then you source from. Where's my worm? Yeah. I'm just gonna do... Oh, here we go. I can use this. Poly extrude. Just for my final flourish. Which way is that extruding? Let's go back. Let's try this. See if it works any better. Well, that's kind of the end of the stream. I've run out of time. I might keep working on this, but next week I actually have something kind of cool to work on. Kitbash are providing me with an asset pack, and I'm going to be just working with it and doing something interesting, seeing what I can come up with. It's the Treasure Island pack, if anyone's interested. And yeah, I'm just going to see what I can come up with. I mean, there's some really interesting assets in that pack. There's like a pirate ship, which I thought would be quite cool. I've had a project in mind for doing something with a pirate ship in the water and a kraken destroying it, which I think would be really cool. But yeah, you know, there's lots of things that you could do. It's a whole kind of pirate seaside town that you could create and destroy or set fire to. So I think that'll be a lot of fun. And yeah, you know, it'll be really cool just to play with some sweet assets and also show you guys how you can set them up for destruction and do all that sort of stuff, like I've done before. But you know, be a bit different. I'll try and create a full scene this time. So yeah, that'll be a bit of fun, and then I might pick this one up again at some point, just to try and finish it off, or you know, something else. Got a big list of effects that we can work on, so we can move on to something else. But hopefully this, you know, kind of gave you some ideas of how you could do stuff in your own work and you know, use some interesting techniques to create different effects. Thanks guys. Yeah, I had fun with this, and I love sharing this stuff with you guys, so thank you very much for joining me. And yeah, I'll see you same time next week, and we'll be doing that cool Kitbash project. So that's it from me. Have a good week, everybody. I'll see you next time.